We all hear it, right? AI is going to make software development faster than ever before. But what if all that speed comes with a hidden price tag? What if it messes with the actual sanity of your code? Well, in this explainer, we're going to dig into some fascinating new research that pits raw development speed against long-term code quality.
All right, let's jump right in. To really get what's going on, you first have to know who the players are. Because right now, in the world of coding, there are really two main types of AI assistants that developers are turning to.
And this lays it out perfectly. On one side, you have what you might call the copilot. This is your helpful sidekick, the tool living right inside your code editor, suggesting lines of code and auto-completing your thoughts. But on the other side, you've got the autonomous agent, and this is a whole different beast. It's not just a sidekick, it's more like a new team member that can write, test, and even merge code all by itself.
Now, for a while, the common thinking has been pretty straightforward. If a little AI copilot is good, then a super powerful autonomous agent has to be way, way better, right? The assumption is you can just drop one of these things into any team and bam, productivity goes through the roof. But, does that actually happen in the real world? A group of researchers decided it was time to get past the hype and really put that big assumption to the test.
So, this was the central question they set out to answer. When a team really starts using one of these autonomous AI agents, what truly happens? What's the real impact on how fast they can ship code, and maybe more importantly, on the quality of that code? And to figure this out, they didn't just run some small, quick experiment. No, they did a super rigorous study looking at open source projects over a long stretch of time. They cleverly matched up projects that started using these agents with very similar ones that didn't. This way, they could actually isolate the true cause and effect of the AI. So they started crunching the numbers, looking at things like how many commits were made, how many lines of code were added each month, all that good stuff. And when they got the results back on how fast these teams were moving, well, let's just say it was not what most people were expecting. So here's the million-dollar question. Do these agents actually deliver on that big promise of speed? The data gives us a classic answer. It depends. And what it depends on is actually really fascinating. Okay, now this is where it gets really interesting. This chart tells such a clear story. If an autonomous agent is a team's very first time using any kind of AI coding tool, they see a huge, immediate boost in their speed, just a massive gain. But, and this is the kicker, if that team is already using an AI copilot in their editor, adding a powerful autonomous agent on top of it gives them almost no extra speed at all. The benefit just vanishes. And the researchers, they put it pretty bluntly themselves. This points to a diminishing return to AI assistance. It totally challenges that myth we talked about earlier, this idea that just piling on more and more powerful AI will automatically lead to bigger and bigger wins. It turns out it doesn't work that way. But the story doesn't end with speed. Not even close. Because while those speed gains might be a bit of a mirage, the research uncovered something else. A much more troubling and kind of sneaky side effect. The first warning sign? The projects that brought in autonomous agents saw an 18% jump in code warnings. These are the little red flags that pop up. Potential bugs, style problems, things that your tools tell you might be an issue. And then there's this. Honestly, this one is the real showstopper. They saw a 35% increase in the code's cognitive complexity. Now, what does that mean? It's a direct measure of how hard the code is for a human being to read, to understand, and to work on safely later on. That's a huge jump. So, what's the big takeaway here? It seems the AI is creating a whole new kind of technical debt. The researchers actually coined a term for it: agent-induced complexity debt. You get this short-term burst of speed, but you end up paying for it later with code that's harder to maintain, riskier to change, and probably full of hidden bugs. So, this brings us to our last section. How do we use these incredibly powerful tools without, completely drowning in all this new complexity? It turns out there's a smarter way to play the game. Look, the conclusion here isn't that autonomous agents are bad or that you should avoid them. Not at all. It's really a call for all of us to be a lot more strategic. We have to stop thinking about just adding AI and start thinking about how to integrate it intelligently. So based on everything they found, the paper lays out a pretty clear 3-step playbook. First, you've got to put stronger quality safeguards in place to catch these problems early. Second, you need to track your code's provenance. You have to know exactly which bits of code were written by a human and which came from an AI. And third, you deploy these powerful agents selectively. You put them on the tasks where they really shine, instead of just letting them run wild across your entire code base.
And all of this leaves us with one final, really important question that every single development team needs to be asking itself right now. As you bring these incredible new AI tools into your workflow, are you using them to build a better, more stable future? Or are you just racking up a huge complexity debt that your future self is going to have to pay back with interest?